Good day, everyone. Welcome to Quantitative Methods with Simulation and Modeling. Last meeting, we talked about supervised machine learning. And with this, we also discussed about regression. And specifically, we talk about the linear regression, multiple regression, and logistic regression. This time, we will be talking about the classification and regression tree, also known as CART model or algorithm. CART algorithm is a predictive algorithm used in machine learning. It actually explains how a target variable's values can be predicted based on other values, such as in this particular tree, wherein there is a root node, internal node, and the leaf node. In the decision tree, nodes are split into subnodes on the basis of a threshold value of an attribute. The root node is taken as the training set and is split into two by considering the best attribute and threshold value. Further, the subsets are also split using the same logic. This continues until the last pure subset is found in the tree or the maximum number of leaves possible in that growing tree. Let's take an example, a look on how these three are split. So CART basically utilize Gini or GINI impurity to split the dataset into a decision tree. It does that by searching for the best homogeneity for the subnodes with the help of the Gini index criteria. So Gini index is actually a matrix for the classification tasks in CART. It stores the sum of square probabilities of each class. It computes the degree of probability of a specific variable that is wrongly being classified when chosen randomly and a variation of the Gini coefficient. It works on categorical variables, provides outcomes either successful or failure, and among others. And hence, conducts a binary splitting. So to compute the Gini impurity for a set of items, suppose we have an I element of 1, 2, up till m, and let f of I be the fraction of its labeled with the value of I in the set. This is the equation process of how we compute the Gini impurity. So the degree of the Gini index varies from 1 to 0, where 0 depicts that all the elements are allied to a certain class, or only one class exists there. The Gini index of value 1 signifies that all elements are commonly distributed across various classes. And finally, a value of 0.5 denotes the elements are uniformly distributed into some classes. So mathematically, we can rewrite the longer version, the shorter version of the previous calculations of Gini impurity as follows. So we have Gini is equals to 1 minus the sum of I, where I is equals to 1 to n, times pi squared, where pi is the probability of an object being classified to a particular class. So a CART model or representation. CART models or classification and regression tree models are formed by picking input values and evaluating split points on those variables until an appropriate tree steps to create a decision tree using the CART algorithms. First, we have to look into the greedy algorithm. In this, the input space is divided using the greedy method, which is known as the recursive binary splitting. This is a numerical method within which all of the values are aligned and several other split points are tried and assessed using a cost function. Then we have the stopping criteria. As it works its way down the tree with the training data, the recursive binary splitting method described above must know when to stop splitting. And the most frequent halting method is to utilize a minimum amount of training data allocated to every leaf node. If the count is smaller than the specified threshold, the split is rejected and also the node is considered the last leaf node. Then we go to tree pruning. Decision tree's complexity is defined as the number of splits in the tree. Trees with fewer branches are recommended as they are simple and grasp and less prone to cluster the data. So working through each leaf node in the tree and evaluating the effect of deleting it using a holdout tree set is the quickest and simplest pruning approach. And of course, the data representation for the card, although there's no special data preparation, is required for the card algorithm. So here's an example of a Guinness split criteria, and so was able to develop an example of card decision tree. Okay, so what are the advantages and limitations of the card algorithms? Let's talk about the advantages. The advantages of using card are as follows. The results are simplistic, meaning it's very simple, it's readable, it's very easy to follow. So unlike other decision trees such as forest, okay, and among others. So classifications and regression tree are non-parametric and non-linear. Classifications and regression trees implicitly perform feature selection. So the outliers have no meaningful effect on card. It also requires minimal supervision and produces easy to understand models as experience involved. Whereas in the limitations, we have to avoid overfitting, prone to overfitting. But there are things we can do so that we'll be able to hit, overfitting. We have also high variance, low bias, and the tree structure with unstable. Okay, so what are the applications of card algorithm? Can be used for a quick data as insights. If it can also easily classify blood donors or blood donors classifications. It is also useful for environmental and ecological data. And finally, in the financial sector. Okay, that will be all for the card algorithm discussion. Here are my references. I would like to acknowledge the Machine Learning Mastery websites, Geeks for Geeks websites, and Digital Vijaya websites. Thank you very much for listening. So let's proceed to demonstration time. Okay, everybody please open your R programming IDE. Okay, so we have here our R programming IDE. So first thing to do is to import our data sets. Still, we'll be using the salaries. This is what we are doing before, only that we're going to use the old version, the original file. Okay, so let's locate for that. Salaries over here. So take note that the default value here are all numbers. We will be using those with words. Okay. So salaries over here. Set yes. This is what we need to do. Our dependent variable will be rank, and the rest will be our independent variables. All right. So we have here our salaries. Okay, then let's create a new script. Okay, so let me just assign our data sets to a simpler variable, like say for example, D. And then we have our library. I'll be using the R part. If you do not have this library, what you're gonna have to do is to install it by clicking these tools, click install packages. Then you write here R part, okay, and then click this button install and wait until it is successfully installed. So since I have already, I don't think anyone will install that. So here, then I'll run. Okay, then library. I'll be using the art part plot, and at the same time, the library CA tools. Okay, so this I was able to load already the data sets and the different libraries that I'm going to utilize. Okay, and I'm going to set seed as one random variable for display purposes and output purposes. Okay, let's try to look into the structure of our data sets. So you will see here that the rank, des, and sex are still characters. Okay, let's try to change this into a categorical variable. So I'll change that to a factor. Okay, so D color rank. I'll be using factor function D dollar rank. Right, so I'll just copy twice. Change this to this. This sex. Okay, this. Let's run. Let's try to get again the structure. All right, there you go. So our rank now is a factor with 3 levels. This one has 2 levels. Same thing with our sex. There are also 2 levels as male and female, respectively. All right. So next thing to do is let's try to get samples, or rather, let's divide our data sets into 2 portions. We will have our trained data sets and test data sets. The purpose of this is that our trained data sets will be used for training the model, generating the model, and the test is for us for the testing purposes. Okay, so let's say, for example, we having variable sum. Okay, and then from CA tools, I will be using samples that split. Okay, so we have here our data sets that will be sampled. Since our target variable is rank, I'll use rank. Okay, so we have here the split ratio will be 80% for the trained data sets. The rest of 20% will be used as our testing data sets. Okay, so let's try to create our trained data sets. This will be a subset of our data sets from above with our sum equals 3. Right? And for our test, the same. The subset of T where sum will be false. Let's try to look into the dimension of our 2 new data sets. Okay, dimensions of the train data set. Okay, so there are 318 data sets with 6 variables. And then we have, let's try to look in also the test data set. There are 79 data rows with 6 variables. Okay, so next thing to do is to create our model. Let's create our model. So let's say, for example, our model, so variable mode 1, I'll be using the rpart function. Then our target variable, of course, is rank. I'll be utilizing all the variables. Okay, so the data sets that we'll be using is from the trained data sets. And our methods will be class, of course, because they are classified as associate professor, assistant professor, and professor. Right, so let's run. So we have our model now. Let's generate the tree model by using the R part plot. Okay, so mode one, what type of our model? Let's say S0 and extra will be since this there are four or three or more, we'll be using 104. If it's only two values of our target variable or dependent variable, we'll be using 102. So since there are three, we'll be using 104. Okay. The digits of our data to a maximum of 3 digits only. For the fallen leaves, the symbol. So their concerns here. Okay, so we have here now our model. It says that if we are going to convert this to a pseudocode or a model text, it will be if your years in PhD is less than 13, if it is yes, then you proceed here. If your years in service is greater than 0, if it is yes, you go to you are predicted to be an associate professor. Okay. Whereas if you say no, if it is less than or equal to 6 years in your service, you are predicted to be an assistant professor. Okay. Going back here at the top, if you said no, then there's another condition. If your salary is less than 88,700 and so on and so forth, then if it is yes, if your years in PhD is less than 46, you are predicted to be a professor. If you are more than 46 years as a PhD, you are predicted to be a professor. If your salary is greater than this amount, then you are predicted to be a professor. Okay, so that is our tree. Let's try to get the details about our tree. There you go. So the descriptions. Okay, so this is the one that I'm talking about. Our root node. So years in service. So it's round off to 13. It says a professor with the values, the percentage of how it is being presented. Okay, so let's try to look into the summary of our summary of our. Okay, so let's have furthermore. Let's do some. Let's try to classify our model by utilizing a confusion matrix, so we can display how many are into that are how many are correctly predicted, incorrectly predicted. Okay, so I'll be utilizing a library called Caret, so I can access the confusion matrix function. Okay, so we have here confusion matrix. Of course, I will be using the train data, and our target variable is rank. And for the sample, we'll be using, of course, the train data with the rank. And for the mode, I will be using everything. Right? There you go. So, as you can see, this is a correct classification. There are 8 correctly classified as associate professor. Okay. And then for assistant professor, there are 12 that is correctly classified. You'll notice here, there's this intersection. There are 12 correctly classified. And professors, here there are 149 correct classified as professors. While the rest, such as 12, 31, 33, are called misclassifications. The same thing for here. Okay, so in terms of accuracy, it has about like 53% accurate in terms of prediction. And in the confidence interval is between 0.4 475 up to 0.787, right? And for the kappa statistics, there is about like 5% agreement, 5.68% agreement. For the statistics in terms of sensitivity, in terms of sensitivity, professors has the highest classifications, right? For specificity, you will notice the assistant professor has the highest. For negative prediction values, okay, the highest is 69.95% for professor, and the lowest is 15.68% for associate professor. For the precisions and recall, we have the highest is professor with 69.95% percent. Okay. For the recall, still the same. It's the professor. For the if one value, it's the professor. Prevalence is also the professor. And the detection rate is the professor who has 0.68%, 48.86% rather. And detection prevalence is also the professor, which is 66.98%. And for the balance accuracy, you'll notice that it's still professor, but they are almost very near to each other. Okay, a really low balance. Okay, so let's try do some predictions. So let's do some predictions. Okay. So I will be using a variable friend as our prediction variable. Okay, so we will try to predict by using the model that, the testing data sets. Okay, so the model that we use and the test, the training data set. So again, the model that we created, this one, the mood one, this is it. Okay, this is as represented in 3. And the data sets that we're going to use to test will be the test data sets. Let's run. Okay, let's try to see what happens. Okay, there you go. For our first data from our data sets, testing data sets, is predicted to be a professor. Okay, whereas here on the 5th, it is predicted to be an associate professor. That's the highest. Okay, on the 6th, still the professor as predicted. This one here as an associate professor, right? So on and so forth. Whereas here, you can see that it is an assistant professor. The 14th participant or respondents is predicted to be an assistant professor. Okay, that is through the use of this model. Okay. So let's try to call this. Yes. Let's try to create the confusion matrix of our test data sets. So instead of that, I'll be using test. Test. All right, so there you go. This is how it is being predicted. There are 3 associate professors correctly classified, while there are 2 that is a misclassification when you're supposed to be the associate professor, but they're classified as assistant professor. And there are 8 who are misclassified as professor, but they are classified as associate professor, but they are classified as here. It's a misclassification. They are classified as professors. The same thing here. It's the correct classification, and these 2 are the misclassifications. While here, this is the correct classifications, while these 2 are the misclassifications, respectively. Okay, so that will be all for this time for our classifications and regression. I hope that you learned something today in terms of designing, creating models of using a cart or classifications and regression tree, and at the same time learning its descriptive data here that needs to be explained and its meaning in terms of their predictions, the accuracy, the confidence interval, the gamma statistics, and the sensitivity, specificity, precision that we call the if one are all very, very important to the person. Okay? So thank you very much for listening. See you again next time.